So the next chapter is probability theory. Now in this probability theory, they will ask you questions of 2 marks, 6 marks as well as 14 marks. You will have one question for each of these sections, section A, section B, section C. One question will come compulsorily. Quite easy chapter, but then again you will have to understand the logic of solving the probability theory. So let us first understand what is probability theory. Okay, so the first part is the introduction here. What is the experiment? Now probability theory is easily understood by an example. Now let us take an example. You all would have put toss. Everyone would have put toss for the cricket match, or somewhere you would want to do, you want to play something. Yes. Or you would have played snake and ladder. Have you all played snake and ladder? Yes. Now in snake and ladder, you will use the dice. You will use the dice which will give you one number, and so many numbers you will be going as per the number, right? So if the dice says 6, you will go for 6 steps. Then if the dice says 2, then you will go for 2 steps. Suppose if there is a snake there, you will come down to its tail. Suppose if you get a ladder, you go up. Correct? Now that dice, when you just shake the dice once and put it onto the ground or onto a surface, it will show one number. Correct? Now how do I clearly say, or how do I know that it will show me 2, 3, 4, 5 numbers only? Now what we were doing when we were playing was just for fun. It was just for fun. But there is a huge theory behind that dice which has been prepared. Okay. So all that, whenever we roll a dice onto a surface, that getting a particular number is an experimentation. I am experimenting which number will I get when I roll a dice. Okay. Now you would have played another Indian game like Ludo. Okay, it's very similar to Ludo, where we used to play it on the rock and all that. Okay, it's a similar version of Ludo. Now even in Ludo you will roll the dice, no matter the Ludo is in online or you're really playing Ludo. You roll the dice. Now whenever you roll the dice, what is the possibility of getting 2 as the number only? Okay, for that there is a theory which we are learning. Now people, you might think, where can we use all this? Firstly, we will be using this to predict what can happen in the future. We are not talking about astrology. Okay, we are trying to find out the demand for the product. We are trying to analyze what should be the supply for the product. That is the business application for this probability theory. Okay. Now here we will not get answer at a time. We are going to consider all the possibilities that we might get in all the possible situations, and then out of that we will select the one thing. Are you all able to follow? Are you all able to follow? Okay. Now suppose, let's say we are playing snake and ladder. Okay. We will have a dice. Dice will be something like this. No, this is a very bad dice. Okay. So something like this, it's a cube. Okay. Imagine it's a cube, and you will have dots on the dice, right? The dice, whatever you'll be using, you'll have dots. So you'll have 1 dot. We'll make it a little bigger dot. Okay. 1. Let's say there is 5 here. and let's say there is 3 here. Okay, to the other side there is 2, and backwards there is 6. Okay, and down here to this side, what is left out? 4 is left out. Okay, so suppose this is a dice. Imagine this is a dice. Now when I roll this dice onto the surface, okay, now in the snake and ladder game, imagine this to be a snake and ladder. Okay, this is very bad snake and ladder, I cannot help it for the example. So suppose I am at 99. I am the first one to reach 99. Now I want only one where I can reach 100 and win the game. Okay, now what is the possibility of me getting that one? When I roll the dice, I should get one. I keep praying, okay, I should get one, I should get one. But how will I get one that easily? Now here it's a fun game, but the same thing when they use it in the business. What can be the scenario where my demand of the product would increase? What can be the scenario where the demand of the product would decrease? Okay, if they are trying out vaccine, now they are trying out COVID-19 vaccine, they're doing a lot of trials on human being, not on animals, but human beings, right? So they will check the whole vitals of the human being whenever the vaccine is given. So whenever whoever gets the vaccine, their vitals means their heartbeat rate, that BP which keeps fluctuating up and down, the body temperature that they have, okay, what is their stamina, for how many hours will they be able to walk freely without any tiredness. So they will be under full observation. Now that is an experiment. Okay, that is an experiment. Now for this probability theory, we have to do a experiment. Experiment is trying out a lot of things. Okay, now if we randomly pick people and if we do the trials on them, if we do the COVID-19 trials on them, that is known as random experiment. We are not calling specific people. We are randomly taking 3 or 4 and we are injecting them the COVID-19 vaccine, and we are trying to check their body condition. So that is known as random experiment. Are you all able to understand the concept? So firstly, we are doing an experiment, and in that experiment, the result may be positive, the result may be negative. We don't know. Okay. Now when I roll the dice, I may get 1 and I can win the game, or I may get 2 and I can still lose the game. So there are 2 outcomes. So I may get 1 and I can win the game. This is one of the result. So I can take this as one possibility, or I can get any other number. Any other number from 2 to 6, I can get any number here and I can lose the game. Right? Now you are playing cricket. Now you put the toss. Okay? If you say you want heads, if the coin is on heads, then you win. Okay? If any other result comes, then you lose. So there are 2 possibilities. What are the possibility here? Either you get a head or you get a tail. So whenever there is one coin, you will get a head or you will get a tail. Correct? You cannot get both together. You cannot get a head and a tail together. That will not be possible. Right? So you are supposed to understand this, where we are doing a random experiment for this, and this random experiment will be considered here for the probability. Okay, and whenever the result has possibility, let's say for example, they are asking you to write the examination. Okay. The result of the examination may be fail or maybe pass. Right? Those are the two criteria we consider. Maybe fail or maybe pass. So two possibilities are there where you can fail all the subjects or you can pass all the subjects, or there is a mixture of all the subjects. You would have failed few subjects, you would have passed few subjects. Right? I have the probability, I have the chance. Probability means chance. I have the chance of getting different options and I will select the best option. Are you all clear until here? Any doubts? Any doubts until here? No doubts. Good. Now, one more example we will take. Now, let's say you have bought a white shirt, t-shirt, top, whatever you want, you can think. Okay. There is a white shirt. I will just take it as shirt. Now, for this white shirt, which all color bottom wear can you use? It can be a legging, it can be a jeans pant, it can be a normal cotton pant, anything. Say me the colors which will go with white. White shirt and which color will suit? Say me the options. Come on, say me the answer. We can go with black jeans or black pant or black skirt or black legging, anything in black. So black will go along with that. Then apart from black, which other color will go suit well for the white? Full white and white? Brown. Okay, brown. Then you can just say me the colors. Blue. Okay, brown, blue, white, black. Then any more colors you want to add? Blue, again, you have lot of shades of blue. So you can try with dark blue, light blue. Red, okay. Red is another color. Now you have got so many options, right? So this option, when you do a combination of the colors, white with white top, let's say you're gonna wear black jeans. This is one combination. With white top, you're wearing brown jeans. This is one combination. With white top, you're wearing blue pant or blue skirt. Okay. With white top, you're wearing red color. Or you're wearing full white and white. Or you're wearing shades of red, shades of blue. Now, these are called as combinations, where you keep one point or one of it to be constant and you take a chance with the other color and try it out. So this is a combination. Understood the concept? This is a combination. We are doing permutation and combination. Especially combination is one thing which we'll be using throughout this probability. We will try and check which combination will work out. Same thing goes with your food. Okay. Same thing goes with your food. Now, for few of the vegetables, you should not add other vegetables. Sometimes you should not add vegetables and fruits. Right? Sometimes for non-veg, few vegetables will not be suitable. It will change the taste completely, is what I have heard though. Okay. So all of these are combinations which you'll have to make. A proper combination will give you the best food outcome. Okay. The final dish, whatever you get, that will be called as outcome. Suppose you are wearing a white top with a blue jeans. Now you're wearing a all matching for that. Girls, say suppose girls are wearing everything matching for that, earrings and hairband, and you have a lot of accessories to wear, right? So you're wearing all of that. So you will be looking, you feel that you're looking very beautiful today. That is the outcome. So that the good feeling what you have is your outcome. Okay. So in an experiment, especially a random experiment or a probability experiment, the final result or the possible results that will come are called as outcome. Excuse me, outcome. So you'll have to understand that outcome. Okay. Now, one more example which they have given here. Let us understand this. The water temperature. Now, water is boiled. Okay. Now, let's say we are boiling the water, or we are heating the water to drink. Now, to drink the water, if I boil it for 15-20 minutes, can I drink that hot water? Can any person drink that hot water? Yes or no? 15-20 minutes I am boiling the water. Guys, quickly answer. Fifteen 20 minutes, if you boil the water, you will not be able to drink it. It will just go away. It will become, it will evaporate. So we are experimenting with the water boiling to a certain extent. Let's say we just heat the water for 3 to 4 minutes. It will not be too much of heat. Now we'll heat the water for another 2 minutes. So 6 minutes. Okay. At that 6 minutes water heat, we'll be able to drink. So our throat will be able to bear the heat. Okay. So we are experimenting here. Okay. We are experimenting here with the heat or the water temperature. Fine. So that is also a random experiment. Did you all understand about the experiment? Okay. Now let us see what they have given to us as definition of experiment or meaning of experiment and all that. So a process which yields well-defined results or statistical data is called an experiment. So we are doing a process. Let's say we are preparing chapati. Now the chapati dough, whatever you prepare, right? You put that atta and you mix, put little salt and you put water and you will start mixing it. Now, after mixing for some time, you will realize that the water is more. Okay. Now we will put little more dry atta for it to balance it. Correct? So, sometimes when you're cooking it for the first time or something, when you have no idea, there might be chances of you adding more dry atta or adding more water, and you keep kneading the dough for a longer period of time. It's a process which will yield to one result. What is the result? You will have a chapati dough. Now with that chapati dough, you will prepare the chapatis. Okay. So we are trying to convert that into a statistical data. Anything you can convert, no problem. Tossing a coin, head or tail, that possibility I can convert it into a statistical data. And experiment, that's called an experiment. It's a process which will give you the defined result, and that statistical data will be called as the experiment. Now, an experiment when performed repeatedly, when you repeatedly perform that experiment, you will get different outcomes. Now, let's take for the same chapati example. Now, we are preparing chapatis. Okay. Now, every chapati will be in a different country shape or different continent shape, right? You are repeating the same experiment. You are pressing the chapati dough. Every time there is no the possibility of having it round every time is very difficult. So you can get different shapes. So that is the different outcomes that you get when you do the experiment. So the experiment when performed repeatedly under similar condition. Now similar condition means we have mixed the dough there and we are not trying to make chapatis. We are rolling it out. Now it's a similar condition, but the result and outcomes can be certain or uncertain. Few chapatis will come in at least in the shape of continent. Few will start tearing in between. So you will take that out and do it again. Okay. So like this, when you have lot of certain means definite result and indefinite result, then in that case it is called as deterministic experiment. This is a new name. So experiment formed when the outcomes are certain, when you actually know what will be the result. Now you know that the chapati dough is proper. You have started rolling it out. Now chapatis will come good. You know it. That is called as deterministic experiment. The scientists are very sure about their COVID-19 vaccine. Okay. They know that it will not affect the people. That is deterministic experiment. You are very sure about it. Okay. So the example for deterministic experiment is the same water boiling that we took. So we are going to boil the water for 6 minutes or maximum 7 minutes so that will be the proper heat for us to drink that water. But if you see the same water being heated for taking bath, when you want to shower, if you are heating the water, no matter it is geyser or solar or you're manually doing it, you will leave it for more number of time. You will leave it for 15-20 minutes because the amount of water is more and the heat that you want to have the water is also more, right? But you know that if I switch on the geyser for 15 minutes, what will be the heat? If I switch on the geyser for 20 minutes, what will be the heat? So the result is very definite for you, and in those cases it is called as deterministic experiment. Understood? Understood deterministic experiment? Good. Now, next, an experiment which does not have a certain outcome. So we understood that when it is definite result, it is called as deterministic. When there is no definite result, okay, in that case, it is called as random experiment. Uncertain outcome. You do not know if that biryani will be very tasty or if that is less of salt or less of chili. You don't know anything. You're just preparing it for first time and you've just kept it on the stove. It's a random experiment that you're doing. Few of them will have weird combinations of eating things. They will have sweet, too much of sweet, and then few will have a little chili part, or they'll have a weird way of eating things. They're randomly experimenting on all sorts of food. When you roll a dice, when you're playing snake and ladder, when you roll a dice, you don't know which number you will get, right? That is a random experiment. You're randomly rolling the dice where you don't know which number you'll get. right? And even when you're playing Ludo, even when you toss a coin, all these are random experiment. You don't know what is the outcome. It can be head or it can be tails. The outcome can be anything, but you don't know. So that uncertain outcome is called as random or probabilistic experiment. Okay, so there are few examples. Body temperature at different time frames. Morning, early morning, when you wake up, your body temperature will be a little low. Okay, as and when the heat outside increases, the sun, if it is a sunny day, the body temperature because of the outside heat, it will increase. And that is why during summers you feel so hot, because your body temperature increases. And when it is winter, you feel so cold because outside the temperature is low, and your body has to maintain that minimum temperature for you to survive, right? So the body temperature can be changing. So that is a random or a probabilistic experiment. Okay, now the gender of a baby to be born. Now in India, you cannot have the gender revelation, correct? So you don't know which baby will be born. No matter, for the, let's say there is a person, you don't know which baby is to be born for that person, for that mother. That is a random experiment. That randomly the gender of the baby will be there. What is the possibility? It can be a boy, it can be a girl. Okay, that is a random possibility. Then what is the demand of the product? Now, who knew that 2020 there would be coronavirus and they will do lockdown and all the factories will get closed? Nobody had so much idea. People were happily planning for their sales to increase, demand to increase. They have lot of big plans for the companies, right? So that in a case is also a random experiment. So we understood what is an experiment, what is a deterministic experiment. When the outcome, when the result is certain, it is called as deterministic. Okay, when the outcome is not sure, when you don't know the outcome, that is called as random. Clear? So that is complete experiment theory. Now, probability theory is concerned with analysis of random experiment. So when we roll a dice while playing Ludo or Snake and Ladder, we have to analyze, when will I get 1, when will I get 3, when will I get 5 or 6. We analyze that experiment. Okay, we analyze that situation and then we will get some hint of how it is done, and that is called as probability theory. Understood probability theory? Okay, next. So probability is a numerical measure of chance of occurrence of an event. Numerical measure of chance. Now if I get 1, 2, 3, 4 in that dice, okay, so that's a numerical chance. I know which number will come. Next, probability has originated from gambling, like throwing a dice or coin. The first book published on probability was Book on Games of Chance. So this is not today's concept. You would have heard about casino, or there were many gambling places before, especially in villages also. Even today, they will have one place where they sit and play cards, right? All that is part of the probability theory. What is the chance of them getting a particular number card? Okay, all that is a probability theory. Now using this probability theory only, you can see all those games today: rummy, online, poker, and before you had this solitaire. That was the one game which used to come with every computer, and everybody used to play that game. Now all that, how did they computerize it? How do we play it on computer? It is on the basis of this probability theory. Okay, the behind work that happens is the probability theory. Even chess game, what is the possibility of the opposite person moving the queen, king, or horse, or elephant, or the soldier? Now you would have heard, no, in Mahabharata, Shakuni, whatever number he says and he rolls the dice, that number will come. Correct? You would have heard a lot about that. That is a game of chance, where he had controlled that dice, that that game of chance he had controlled in such a way that whatever the number he told or he thought would be falling there. Right? So that is unethical, but then that is how his character was. So that is also a game of chance. Now game of chance is there from so many years, so many decades. So it's there from ages. Now later we started using this in business. We started trying to solve our problems from business, and then it became part of statistics, where we will be learning them in statistical inference and decision theory. Okay, so that is the little part of history of probability theory. Then coming to the basic terminology, we have a sample space. So we'll have to learn few basic terminologies before we get into the problem. So we have sample space. Now sample space means what are the possibilities that I can get. Now when I toss a coin, what is my sample space? What is the possible result? I can either get a head or a tail. Okay, when I roll a dice, what is the possibility? I can get the number from 1 to 6. 1, 2, 3, 4, 5, 6. Any number I can get. Correct? So that is a sample space, and sample space is denoted by S, and the possibilities that we get, the possibility of the samples, the possibility of the outcome that we get, that we write in numbers.